Hi, welcome to the lesson about data processing standalone. So why standalone? Because you don't need the big data processing frameworks and big data clusters for all the workloads. Always remember this sentence I like to recall very often to myself because I enjoy working on the clusters, but still if you have smaller data, you might fulfill your need with a much simpler solution, so-called standalone processing. So do not kill a fly with the sledgehammer. And that's the key point. So always adapt, be pragmatic, and adapt your tools to your problems. If you are processing small CSV files, then maybe deploying a cluster with 5 nodes will not help you that much, even though it's a very fancy technology like Apache Spark, Apache Flink, or Dataflow, or any other cool distributed data processing framework. So yeah, that's the thing to remember. And now we are going to see much more details, and spoiler alert, it will be about Apache Spark and Apache Flink also. So what this standalone processing means? So if we take our data pipeline, we have data source and data sink, and in the middle we have data processing. So in the standalone data processing, the processing happens in a single node, but it doesn't mean it uses a single process, because inside the single node we can use multiple CPUs and simulate this concurrent execution with different threads. And to implement the standalone processing, you can use, for example, Docker images deployed on some Kubernetes or batch services on the cloud. You can even use the virtual machines without any containerization, or serverless functions if it also fits into your need, if it also solves your problem. And that's this part where I will talk about Apache Spark in this context of standalone processing, because you can use these distributed data processing frameworks as standalone data processing engines if you enable them with local mode. So in this local mode, the distributed processing is simulated by the multiple CPUs available on the node, and the memory is shared between them, so that you can encounter different things, like for example concurrent access issues when one process removes the data which is created and read by another, and stuff like that. So yeah, it's fun, but it's not that simple as using a single process code, a single thread code. And more concretely speaking, if we take a look at the code, to enable a local mode in Apache Spark, you have to reference the local master node, and in Apache Flink you can create it with a local environment builder. And if you want to see an example of that, I will show you it in just a minute. So let's see the code. The demo is very simple here because I'm illustrating just to recall the standalone data processing, and to do that I will use a Python code and Spark code executed locally, and both will use a data generator that I wrote just here. Very easy. It generates 3 rows written as input.json file under this temporary location. So for the Python code, as I mentioned in this theoretical introduction, standalone data processing can be run from a Docker image, from a virtual machine, and in my example I'm using PyCharm, and obviously it's an example of virtual machine execution. So to process data in Python, I'm using the native CSV package, and the CSV library has a method that can write some CSV data. And as you can see here, the transformation will consist on taking the JSON file and writing it as a CSV file with the help of this CSV library. And of course I have the same thing but for JSON. So as I'm doing here, I'm reading all the lines and later transforming each line to a dictionary and writing it later with CSV writer, with a special treatment for the first row, where in addition to the data, or maybe before writing the data, I'm writing a header with all the columns present in the CSV. So let me run the code, and you can see that I correctly transformed the JSON input into a CSV output with the header and 3 rows I have just mentioned. What happens for PySpark? So for PySpark we have generally the same idea, but we have less code because Spark takes care for all this header, for the JSON loading for us. All we have to do is just to define the schema for the JSON to avoid Spark to auto-discover it, because it's also a cost in terms of processing, and later just to use the right API with appropriate options, so header and override mode to replace the existing files. And let me run the code right now, and you can see there's standalone processing because I'm using the local master, using all my CPUs available at that moment. And you can see that the JSON file is correctly present, and we correctly transformed it here to some CSVs with this right function. So that very easy. It was all in the demo, and just to show you that we can also process data in local manner without necessarily using the cluster. And if I had to summarize this lesson somehow, I would say that you should use the tool which is adapted to your problem. So as I said before, if you have small CSV files of dozens of megabytes or even hundreds of megabytes, it's not the big data size, and it's a size that can be freely processed in a single machine or in a single thread, and still it may be much faster than doing that in distributed computing, because you must know that distributed computing is not only about processing the data from different places, but it's also to preparing the execution context, so dividing the data set to process into multiple tasks, and also scheduling them into different nodes, which makes this whole process of scheduling and retrieving the generated data on different physical nodes may be much slower than just starting a standalone code and process the small data set you have. But if you want to discover distributed data processing, I invite you to the next lesson. Thanks for watching.